Hey, welcome to the numbers game. I'm Coach T, and in this tutorial, we'll be proving propositional statements using algebraic laws. Those algebraic laws include associative law, distributive law, and more. Let's get started. In this video, we'll be solving and proving propositional statements with the basic laws of algebra. For the purposes of this video, we'll only be using associative law, commutative law, distributive law, identity law, and the law of tautology. Now, these laws may ring a bell, but if you need a refresher on the definitions, I recommend watching our video on the basic laws of algebra. Now let's take a look at a couple of propositional examples. For our first example, we have P and not Q, or P is equivalent to P. Now let's take a look at the left side of the equivalency sign. For our first step, we'll move that P at the end to the beginning. So we have P or P and not Q. The law that allows us to make this shift with P is the commutative law. For our next step, we'll simplify P or P and not Q down to simply P. We are able to simplify this term down to P by the absorption law. Hence, proved. For our next example, we'll solve not P or Q, or P and not Q. Now we'll start by rearranging the parentheses. So let's rewrite this as not P or open parentheses Q or open parentheses P and not Q. And we'll close both parentheses. Here we use the associative law to rearrange the parentheses. Now for our next step, we'll distribute the Q, giving us not P or Q or P and Q or not Q. To be clear, here we distributed the Q to P and the Q to not Q. And this is by our distributive law. Here we see that we have Q or not Q, which gives us a tautology, leaving us with not P or Q or P and tautology. And this is by the tautology law. Once we prove that tautology, we can get rid of the T, simplifying to not P or Q or P. By the commutative law, let's group our not P and P together, giving us not P or Q. Not P or P gives us another tautology. So we have tautology or Q. And finally, we have proved that our original statement is a tautology by the identity law. So here we have found that not P or Q or P and not Q is always true. Alrighty, so this is how you use algebraic laws to solve or prove a propositional statement. In our first example, we proved equivalency in the propositional statement. And in our second example, we proved the propositional statement was a tautology. As always, I'll leave you with an example to try on your own. Show that the propositional statement P and not Q or P and Q is equivalent to P and not Q or Q. If this video was helpful, give it a thumbs up and also subscribe to the channel for more calculus and proof topics. And thank you for watching The Numbers Game.